All right, so this problem is gonna let us practice the idea of stress and strain using Young's modulus to determine how much a object, a solid rod, is compressed during a situation. So this problem reads, during a wrestling match, a 150 kilogram wrestler briefly stands on one hand during a maneuver. How much does the upper arm bone shorten in length when he's standing on that one hand? We're going to represent the bone as a uniform rod of 38 centimeters long with a diameter of 2.1 centimeters, a radius of 2.1 centimeters. So we can imagine that we have this wrestler, here he's upside down, he's standing on this one arm. Okay, so that's sort of the picture that we're going to take. And because we're compressing this arm, that's the situation that we want to examine. So we want to think about the idea of compression. And we know that the change in length of something that's being compressed is given by the relationship 1 over y, where y is our Young's modulus, times the force per area acting on that object, times its original length. So it's dependent on all of these pieces. So we first have to appreciate what is Young's modulus for bone under compression. And that's a known quantity, an empirical quantity that we had to evaluate experimentally. And we know that bone is 9 times 10 to the 9th newtons per meter squared is its Young's modulus constant. We also have to appreciate what force is acting on this arm bone. Well, we're going to assume that all of the weight of the wrestler is above that arm bone. So the arm is going to be a real small portion of the whole wrestler's weight. And so the force acting down on that bone is the weight of the wrestler, the force of gravity. So that's going to be m times g. We're given that the wrestler is 150 kilograms times 9.8. So the force acting down on that arm is 1470 newtons. All right, we also need to appreciate the area over which that force is acting. So that's the cross-sectional area of the rod of bone that we're talking about. So we know that area is equal to pi r squared. We were told to model it as a cylinder. That is then pi. That cylinder has a radius of 2.1 centimeters, so 0.021 meters squared. And that gives us a area of 0.00139 meters squared. All right, and then the final piece that we need to make sure we appreciate is its original length. So we're told that it is 38 centimeters long, so that's 0.38 meters long. So we want to make sure that if we're going to use the Young's modulus in newtons per meter squared, that our forces are in newtons and our dimensions are in meters, our length dimensions. All right, so now we just plug in those values for our situation. So we have 1 over 9 times 10 to the 9th. Our force is 1470. Our area is 0.00139. And our original length is 0.38. And we find that the change in length of this situation is 4.46 times 10 to the negative 5th meters. So that's 0.0446 millimeters. So just a teeny amount, 0.04 millimeters of compression acting on that bone. All right, so using the relationship for compression. Good job.